There we go.
Sci-fi sound effects going.
So that should be working.
That works, yes.
On the screen. Voila.
Hey.
Okay, so yeah, welcome to the event. Welcome to Unstructured Volume 2. So there's a few people watching online as well. Hopefully the sound and everything is working for them. They can see you and they can see the slides, hopefully fine. Yeah, let's get started. And I'll tell you a little bit about us, first of all, your hosts. So my name's Stephen. I'm one of the co-founders of Tilo. One of my other co-founders is Stefan, who's sitting there. And we're a very new startup, really only founded at the end of last year. And we came from a credit bureau in Germany, where we were developing what's called entity resolution technology. So here's our pitch. You know, we believe the most successful companies in the world are turning data into competitive advantage, whether it's using data for understanding their customers better, for doing better marketing, better advertising, or for kind of fraud prevention, or know your customer or something like that. But the problem is that a lot of companies have tons of data, but are unable to use that data properly because it's bad data. And that holds back this potential. What do we mean by bad data? The bad data that we try and help people work with is the similar non-identical duplicates of data, data which is related but unconnected, data which is held in disparate silos and therefore can't be linked together well, databases that are inherently out of date. Data provenance is always an issue. You never know properly where your data is coming from, and hence if you have the legal right to even use that data. And then even if you've got systems which allow all that, you will often encounter scalability and performance issues, with the result that, as IBM says, 70% of organizations are unable to generate value from their own data. So what we do at Tilo is something called entity resolution, which might otherwise be called deduplication or record linkage, but it's basically the connecting together of similar non-identical data in a way which makes it usable at scale and in real time. And here I've just got a kind of a fake example of what that means of a person. Maybe they're going through border security and they have data that says that this Walter Smith is actually a UK citizen with a particular address in the UK, and we know his date of birth. You may have other data which belongs to the same person. Walt Smith is the same as Walter Smith. There may be extra metadata in there, such as their email address or their gender, whatever. But you don't want to necessarily search both of those parts of data to get the one result. And that is a case for deduplication of data. And say this Walter Smith is not just a UK citizen, he's also a German citizen with a German address. Those two data sets are different, but they should be connected together. And say that Walter Smith has also got extra data about his German data. That's another deduplication case. And that data of Walter Smith here might be connected to the Igor Smith here. Now, under normal circumstances, that sort of data is very difficult to actually deduplicate and connect together in real time. And it's very difficult to do when you've got large volumes of data coming together. But that's basically what we've optimized for. This is what data conceptually looks like when it's in TiloRes, our software. We have this kind of graph structure for connecting deduplicated data together, and those mini graphs are connected together. So these nodes of data are connected together. And our real strength is that you can search data at one end of these nodes and get the result of any of the other nodes in a consistent 150 milliseconds, no matter how much data is in there. For any sort of real-time use case, such as fraud prevention or security checks, that is very, very useful. So we wanted to put on a speaker series just talking about data science and business. We didn't want it to be too scientific, so it's accessible to non-data scientists. So we had our first event last month where Stefan gave a talk about some of the methods we use for geolocating data. Louis from OneFootball also gave a talk, and Bojan Angelov is another kind of data science CTO in Berlin. You can see all the talks. I will cut these up later and put them onto YouTube. You can see them on tilotech.io/unstructured. You can also find a link to our YouTube channel there. We're always looking for more speakers. So if anybody's got a topic they'd like to talk about that is not too deep into the data science, otherwise I won't know what you're talking about, come and tell me afterwards. I tend to take a lot of photos during the talk, so apologies if that's annoying because it clicks away. I'm also not a very good photographer, so sorry about that. And the last thing is we'll make a donation to UNICEF for every attendee. So yeah, this thought was worth mentioning that. And without further ado, I will hand over to Mikio. Thank you.
Hello, everyone. Oops, my name is Mikio. So, touch the laptop.
Yeah.
Oh, good. Oh, it's just a cable, I
think we might have actually put it into screensavers. Yeah, just left and right.
Okay. Yeah. All right. So I'm okay. What did I? So I did actually. I started out as I did a PhD in machine learning in Bonn. Then I was a postdoc at the TU Berlin here, and then like 6 years ago I joined Zalando and worked on recommendation and search and the machine learning platform. And then I was at Get Your Guide at the beginning of the pandemic, just for 9 months or so. So when you don't have a lot of customers or data, it doesn't make a lot of sense, unfortunately. And then after that, I became a consultant. So for the last 1.5 years, I've been working on all kinds of projects. So and I sort of did everything from like starting computer science, research, and all of that. Yeah, that's what I'm trying to help people with right now. And the title of my talk is What You Need Besides ML to Put ML in Production. So originally, what was the first version of the talk was just what we will hear later on. So yeah, lessons learned from building data science products. Yeah, so we had to find something new. All right. So what is the maybe I move it. Can I move it up here? Oh yeah. Right. So I think you might think, okay, what do you mean machine learning besides machine learning? Right? Isn't it like, so we have AI, right? Everybody knows that. You've seen all the videos, and then you do something, and then you make a lot of money, right? So you would ideally, right? I know. Let's say you want to create a new chatbot, so you download the paper, you pull the model from Hugging Face, something. Maybe you retrain, and then you put it in production. That's it, right? Or so. But unfortunately, it's not that easy. And I think there are, or what I also consistently see, there are things that you also need to learn, right? So unfortunately, it's not sort of in a way we solve the problem, but not in a way that you can just take it off the shelf and use it yourself. And I will talk about in the next 20 minutes, 18 minutes, about 4 different areas. So data collection, how to run data science projects, organizing teams, and to learn which tools to use and which not. So, and I think this is, yeah, it's all besides machine learning, because with machine learning, you usually already have the data set, I think. All right, so data. So as you hopefully probably all know, right? So for machine learning, you need, so it's a way of constructing programs that do something, but instead of writing the program, you let it learn from data. So who of you who has not known that from the people here? Do you roughly know how it works, or? Okay. Yeah, so you need data, right? So that's the whole point. So if you want to have something, so maybe you want to classify emails, or you want to build a recommendation system, or improve your rankings for an e-commerce, or I don't know, do something else, you always need this data. And if you don't have the data, the question is how you get it. And this is sort of my brain dump flow chart of trying to figure out, okay, what are all the options? So like the worst case is if you don't have any data, right? And it could be that, so you just don't have the data. So what you have to do is you have to start collecting the data, right? Or maybe you can buy the data, or you can somehow bootstrap your product in a way that you get the data. So let's say, and this is actually quite common, I think. So let's say if you're in a company, you're selling something, and you want to build a recommendation system, but you haven't collected any of the data, right? So you have some idea what works or what doesn't work, and then you have to start doing it. And it could be that collecting this data is actually really like a big effort. So you have to start, somehow collecting it. Maybe you already have it, but that's a different point, right? So this one word collect could mean like a 3-year project until you have the data where you can actually do something. So another case is you have the data, but not digitally, right? So I've talked to people who say like, yeah, we have like quality control. They wanted to do some quality control on some machines they have. And they said, no, it's not a problem, right? We have somebody check all the machines every day. But it turns out what they do is so they fill in these paper forms with some stuff, and then it gets put somewhere. So you have to scan it, digitize it, and so on. It might be another few months before you have something. Or you sort of have the data, and this is, I think, the most common case. You have it, but it's not in one place. So you have to walk around and pull data from different databases, and that can also take quite long because you have to figure out who owns the database, who can give me access to the database, and so on. On the other hand, so if you have some data, it still might be, you're still not done, right? So it could be that you sort of have data, but it's not labeled. So you have like lots of, let's say you want to do, so you get customer requests and you want to have a system that sort of tells you what it is, so you can route the customer request easier to the right person in the call center. And you sort of, you have like 2 years of data, but the actual information that you want to have is not there, right? So luckily, I think in this specific case, maybe you have a database somewhere else where people actually said, okay, what it is, but often you also don't have it, right? Or if you have, if you go down to the computer vision to figure out, I don't know, defective elements or something in production, then these are usually not labeled. And then you have to hand label them in the worst case, right? So you have to have experts in your company look at the data and then label it. Or you can sometimes also crowdsource it. So you can, there's this thing, Mechanical Turk from Amazon. It was one of the first, I think already like years ago. And essentially you upload your data and then it is shown to people. So people can look at the data and then they can label it and then they get a few cents every time they do that. And sometimes this is the only way, right? And you have to, then you can also be smart about it. And start like with a small set and then figure out if you have enough and so on. All quite complicated. So you could also have data. So I think the standard example is if you have like a website and you want to build a recommendation system. So you have all the tracking data, but then you realize it's very faulty or incomplete. So there are some events which are not tracked, right? Or there are mistakes in there, so you have to fix it another few months. Or you might also have data, like medical data, but there's a lot of privacy issues. So you have to figure out, okay, maybe we need to change contracts with our customers so that we can actually use the data and so on. So it could all be quite complicated. And I think so what you need to learn is sort of to figure out which one of these you have, and then figure out a good way to do that. So by the way, if you have any questions, you can also, of course, always interrupt me. I want to talk a bit more about this bootstrap thing, which I think is quite, I've seen this a few times, which is quite nice. So the idea is, so you have a product and ultimately you think, okay, that's a great thing. This is something where we could really use data in machine learning and do all of that, right? But you don't have the data. So so instead of, but what you can do is, so you can build versions of your product that so the first version of the product doesn't use any machine learning, and it's just there for you to start collecting some data, right? So an example was at Zalando, they talked about it. They had like normal recommendations, and now they wanted to build outfit recommendations where you don't just get like one piece, but sort of like a matching set of items. But they didn't have any information on that, right? So they thought about, okay, maybe we can look into what people bought together and somehow reconstruct it and so on, but they didn't really have something. So what they did instead is they said, okay, let's start just like with an outfit recommendation, which is sort of fed with hand-coded data, but just to make sure that the product itself looks nice and is right? And then, so once they had that out, they had something which they could use to start collecting data. So the second version then uses like some of the feedback from the first version, maybe to do A/B tests, to do some tinkering, maybe add other data sources, and then you have the first version, and then from that you can start collecting the actual tracking data, and then you can at some point do the full machine learning model, right? And I think there are different versions of that. I once talked to somebody from Zeitgold, was a German startup to help like restaurants with their accounting, and they also had some version where there were humans in the loop who looked at the data and then sort of you grow your data set over time. There's also an anecdote that Amazon, they have this Echo line of devices, and then at some point they had one where you could do like a portrait mode picture, take a picture of you. And they said like, oh, it's great, you can take a picture of you and then share it with your friends and they can see what you're wearing. But at the time, people said maybe they're also just trying to collect like collections of people wearing something, and then they would use it later on. So so I think this is a bit more advanced, but sometimes that's also the only way. And if you figure out how to do that, I think it's very nice. All right, data science projects. So this is now in my consulting work, unfortunately, one of the most common problems is that people don't understand that data science projects are really different from normal software engineering projects, right? They think, okay, maybe we hire data scientists, but then essentially we do just the same thing. And the difference sort of is, typically, or those of you who maybe have done a data science project also know that it's a very iterative process, right? So you start with some problem and you think about, okay, how can I reformulate this as a machine learning problem? You get some data, and then you run some experiments. You have some idea, okay, I could use this method, and then you see, right, you do like a first batch of that, hopefully very quickly. So hopefully you already have the data. This is after the 3 months you waited to get the data from that one database where they didn't want to give you access to. Okay, and so if it works out, right, then it's okay. So you can take more data, think about how can I put this into production and so on. But more often than not, it does actually not work out. Right? And then you have to think about, okay, what is wrong? Is it the data? Is it the wrong method? Is the problem formulation wrong? And then you start doing this iteration till you get there, right? And then very often it's like, because the data is always a bit different, you can't really predict how this is going to be. Right, so I think that the basic point is, so there are like projects which are more about execution, right? So you can plan and predict how things are going to work, and there are projects which are more about exploration. So for example, assembling a car, planning a party, doing payroll, right? These are all like processes. It's clear what needs to happen, and you can predict how long it takes, how many people you need, and then you can do it, okay? And in a way, software engineering is often in that space. It's sort of like you give me the requirements, right? I know how to put all this stuff together, and then you get it. Then it takes twice as long, but in principle, it's more or less clear how it goes, right? But exploration, on the other hand, if you invent something, if you start a startup, it's really not that clear. So the path isn't really clear, and that's the big difference. And data science projects for like new data, new challenges is always a bit in the second part, more or less. Okay, now the question, so how do you do? How do you approach these projects actually? And I think so what you need to do is you need to sort of, you need to figure out like what are the highest risks and the biggest unknowns in your data, right? And then you start sort of on the problems, on the stuff where you know the least about and which poses the highest risk. So just an example how that could look like. So this is like one project. So here, the highest risk, biggest unknown is the data. You haven't really looked at the data. The method, like the model, could be a high risk, but you found some papers that solved a similar problem. That's okay. But then stuff like deployment, right? So you've done it before. You used an MLflow, some tool. That's okay. And then performance, you don't really sort of, performance, it's really no risk because you have very little users for that endpoint for whatever reason. right? And then in this case, I would say, okay, you have to start with the data. You have to figure out whether you have the data and so on, and then you can slowly move your way through it. Could also be a different project, right? So I worked on search. Sort of learning to rank is one of the approaches where you use user feedback to figure out what the right ordering is for a search term. And this is one example where it's really, really complicated, like technologically, how to integrate machine learning. Okay, maybe you say more about this.
I'm just really glad someone else is saying bike shedding besides me.
Yeah, yes. So, yeah, if you're working on something that is sort of unknown, but really nobody cares about, then you're in that area. Right. So and here maybe the data is okay. You have it. You know that that you have good data. You used it before, so that's really not something you should focus on. And then this is sort of, so you pick like what is the biggest risk. You try to solve that. You time box everything, that you don't spend too much time on the project, or that at least after some time you ask yourself, is this really worth it or not? And that's sort of the approach. At least in the beginning of data science projects, how you should do it. All right. Teams. What am I doing? Okay. All right, so now sort of you have the data, you roughly know how to do the project, now the teams. So the biggest challenge I always see is because of like the work is different, right? So you have this exploration, and software engineering is more about building stuff. And that's like just a cultural clash you always have. So software engineers, they're like, yeah, we want to do like best practices, you want to have it maintainable, you want to have good processes, everything has to be reviewed and so on. And data science is more like, let me try this thing, and then tomorrow I try something else, and then all the code I written in the meantime I will just throw away because it was just for me there to learn it. Right? And if people don't understand it, there will always be these clashes between these two factions in the team. I think what you should strive for is cross-functional teams where you have data scientists and engineers in the same team, working on the same problem, that they really own it and they can also help each other. And usually, yeah, I would say, so there's a version where you do sort of agile software development with sprints, where data scientists and engineers are in the same sprint. And the only difference is, so for data, so usually you say, if you do agile, you say like after each sprint, you have like one increment, which you can demo and test and bring to the customer and so on. And for data scientists, sometimes this increment can just be some insights, right? So they say, we want to know, like, what is this version, like of these three different approaches, which one is the best? And then you say, after 2 weeks, you want to know, get the insight, want to know what it is. And that's how it works. Yes, and I think you need sort of data scientists who want to learn how to code, and engineers who are interested in working in more experimental fashion. And if you find those, I think then you can have great teams. So if you scale out a little bit, now on the right picture, so if you like on a whole company level, right, how do you do that? I think usually companies start with a version where they have all the data scientists in like a center of excellence or kind of thing where they work on prototypes. And the reason for that is that it's quite hard to find data scientists, so you can't just hire one for every team which needs them. And they also always want to have somebody to talk to, because of all the exploration and discussion. So you have them there. And then the problem with that approach is that it's good to do prototypes, but then once you want to hand it over to the actual team who is using it, there's always this friction, right? So the team already has a plan, they don't know what this new stuff is, and so on. So over time, you want to get to the picture down below with the cross-functional teams. And there's also a version which I've never seen work anywhere, where sort of data scientists, they just do data science, and then they sort of throw it over the fence, and then you have people who are building the model, they throw it again over the fence, and then you have people who run it, right? Yeah, but I've never seen that. Maybe it works if your whole company is already structured like this. So I know people who worked at Twitter like years back, and they said actually they're like in a sandbox, so they have all the data, but they don't touch any production system, and they can work on something, and if it works out, somebody else picks it up. Yeah, but I personally haven't seen that work. All right. Now, finally, technology. So the problem with machine learning is that there are just many, many tools out there. Sorry, I forgot to put Gina AI in the specialized ML libraries toolbox.
It's never too late.
It's never too late, yes. So this is just for another talk I did, right? I just like whatever I found I put down here, and I think you can maybe put like 5 times, 10 times as much products in each of these boxes. Yeah, and somehow I don't know how people do it, right? So you have to really learn a lot of different tools, and it's sort of unclear what a good sensible subset is or a way to start. And that's the sort of the money slide. So either because this slide will save you money, or we will spend a lot of money on cloud services. So in my opinion, so my recommendation, I mean, this all depends on like what is your problem, how much data you have, and so on. But sort of Jupyter Lab, that's like what everybody's using, just the notebooks to get started. Pandas, if you have enough memory just to hold your data in memory, use that. Start using S3 very early on. I think so. S3 is the storage in the cloud. So this is just for like the first step into the cloud, even if you're doing stuff on your notebook, laptop. So scikit-learn, I think, is for the classical machine learning, just the standard TensorFlow, PyTorch for anything with deep learning. There's this library MLflow for logging and tracking experiments from the Databricks people, which I think by now is quite good. So Databricks, they have this extremely successful and aggressive sales force. So at Zalando, they came by every 2 months and said, "Don't you want to buy more stuff from us?" And then one day they also said, we also have this shiny new library, but it was like 2 weeks old. So that was maybe a bit early, but that was like 3 years ago. Yeah. So once you have all of that, at some point you will start about, okay, I want to also have to automate it so that the training happens every day. If you're at that point, right, I think everybody is still using Airflow, although it's a bit old. So you can tell it hasn't been redesigned or it has been designed at a time when there was no Kubernetes and stuff like that. I've looked at Prefect, which is also a library where you can define pipelines and run them automatically, which is quite nice. So one question always is, if you have a model, how do you access the predictions? And most tutorials tell you to deploy it as a REST service. It's quite easy. But there's another thing. So if you can also just pre-compute the predictions and put them in a database, and you never have to deploy the model. Very nice. And then my last recommendation also for this talk is sort of, as much as it hurts, don't invent the wheel at first. So the point is, so I mean, every time, so I've been working in this space for quite a long time. I've written like several versions of machine learning libraries myself while I was still a PhD student. And it's still, like, as I said, it's still like many, many different tools. It doesn't fit together very well. So every time I look at it, I'm like, maybe you should just rewrite everything yourself. But of course you shouldn't. I mean, until after you have something running, and then of course you can spend your time on rewriting everything. All right, so this is the very short, condensed version of what there is besides machine learning to do machine learning. Thank you very much. And you want to do questions now or later? Or? All questions answered.
What cool up-and-coming projects have you seen that aren't on the slides yet, not including us, or our competitors?
Yeah, okay, yes. No, I think the one, so in this whole bunch, right? So the Streamlit thing, I think that was quite interesting. So Streamlit is I think somebody from Airbnb was in a way to have a script, but also a website of to turn a simple Python script into an interactive website, and then you have sliders and can play around with stuff. And then they sold it after 1.5 years for I don't know how many 100 million to Snowflake, I think. And that was really nice. So it's something completely different, right? So it's the first time I saw it, I didn't really understand. So I thought it was magic because it seemed like impossible to do. Yeah, I think the other problem is still there's like everybody's just looking at a small part. There's a lot happening in this MLOps space, but that's just like the last part of the pipeline, right? So there's still, especially like how you get from experimentation to production is still quite unclear, I think.
I can set and stream it. Like if I'm going to show you any examples today, they're using Streamlit. It's really, the company I work for is one of my favorite Python projects. It's that good.
Yeah. It is.
That's the one you got us.
Yeah.
For how many million? I forgot.
Oh,
Hundreds of millions. Yes. Now there's one other, I think this down here, Super AI. Is it that one? Yes. So this is sort of, it's a company that sort of handles model training and labeling for you, right? So I told you before, there's stuff like Mechanical Turk, where you can sort of create huge data sets and it's shown to people and they label it. But here they integrated this with the training of the model. So they're not just getting asked for labels, but also for the labels which the model is still missing. I thought that was quite interesting. Yeah.
So I guess maybe we can be the data platforms. Tilo can go in data platforms, and Gina can go in. Where are you going to go in?
Oh, all of them.
All of them.
Do you have a Sharpie? I'll just draw us in.
Yes. You can just edit the slide. Yes.
I have another question.
Yeah.
So do you have any advice you give to somebody if they started a project where users have to give their information voluntarily, probably knowing that it would be used for some kind of data science? The example that I'm drawing from is, so for example, I'm from South Africa, and there by law they have to ask how old you are if you visit a website to want to maybe book a wine tasting. And a lot of the websites, they would have like an immediate pop-up that says your date of birth was maybe 1st of Jan, 1970. A staggering amount of people were born on the 1st of Jan, 1970 visiting the website.
Yeah.
So when they thought they would use the data for something, they couldn't.
No.
People were not willing to give the information. Do you have any advice about, especially those phases of the project when you need to source data?
Oh, good question. Yeah. No, not really. I think.
Give them free wine for truthful answers.
Hey,
Or in vino veritas.
Trust but verify.
You met people.
Yes. I don't know. Yeah. Okay. All right. Thank you very much.
Mikhail. I'll now see if I can load your talk.
Yes.
Cheers.
It's only 60 slides. It can't be too much.
Yeah, don't be scared when you see Alex's slides. There's
It's full
60 of
cute
them.
animals. It's 60 slides of mostly cute animals.
I'm hoping he's actually got some kind of animation effect when he actually flicks through them so fast.
Yes, I'll give everyone epilepsy. I'm going that quickly.
Right. Well, that worked quite nicely. Okay.
Oh, wow.
Then I'm introducing Alex from Gina AI.
Hey everyone, good to be here. I'm going to blast through this pretty quickly. Most of the slides are pretty basic. How many people here are in data science? Show of hands. Quite a few. How many here know Python? How many here are just here for the beer? Okay, I thought as much. All right, so what is neural search and why should I give a damn? Cute and not so cute animals ahead, fair warning. I'm Alex, Developer Relations Lead at Gina. Developer Relations, basically the engineers do all the hard work. We make it look sexy to the community. We're open source. We want loads of people all around the world to use our stuff. That's part of my job. I really love open source, usually in Berlin. I'm on Twitter, I'm on GitHub. Like I said, blasting through it quick. So take photos because this ain't going to last long. We're going to go over the basics of what neural search is, how it works. Probably won't show you any code because we ain't got time. Gina is a startup in Berlin. We love open source. If you're in data science, you've heard of BERT as a service, Fashion MNIST. We're started by that guy. All those lovely grainy black and white photos of fashion you never knew you wanted. The good stuff's at get.gina.ai, business stuff at gina.ai. We make loads of stuff. Yeah, skipping that, don't have time. What the flip is neural search? So before we ask what the flip is neural search, well, what the flip is search to begin with? Because most people, when we think of search, what do we think of? A boring white little box. You type things, smack enter, pages and pages of results come back. Google, Amazon, Stack Overflow, all of these sites. You all know what search is. But what's neural search? So, oh, my animated GIFs don't work. Oh, I knew it. Sorry, everyone, it'll be a disaster now. We don't have animation. So neural search is basically that kind of search plus neural networks. So Oh, and my hidden slides aren't being hidden. Oh my God, what secrets will be revealed here tonight, people? So one example might be, instead of searching text, you want to search images. You want to run Zalando into the ground and be the next Zalando. You want people to be able to take pictures of their shoes, upload them, and find similar pictures of shoes so they can go out there and impress potential mates. And that's an example of neural search. It's upload a thing, find similar things. We've got an example that, thank God, is finally up and running again, because curse you, Jeff Bezos and AWS. There's a QR code there for if you're masochistic and want to run it on your phone, you can. And this is actually built with Streamlit because it is cool. Also, chatbots are a kind of search when you think about it. You type in a query, instead of getting pages of results back, you just get one result back. Then you type in another query, and, you know, rinse and repeat. And we've got another example of that as well. Again, thank God. Everything, all the examples fell down today. That was fun. Or you could upload a PDF and find similar PDFs from your machine learning library, because that's a thing everyone loves. We don't have an example for that yet. I'm working on it. I'm not one of the cool engineers. I don't understand how to do that bit yet. Or, you know, you could build the next Shazam. You could upload a Beyonce song and find songs from Destiny's Child, because they're quite similar. Or videos. So in short, it's similarity search. This really doesn't work without animation. You'll have to come to one of my other talks when these will work. So how does it work? So the technical stuff is it uses deep learning models to create and compare embeddings to find similar things. We're going to look at that from how we do it ourselves. And it's animal time. So first of all, let's look at some pictures. See, everyone's smiling now. Okay, some of you are only smiling on the inside, but yeah, I'm imagining you all are. So what have they got in common?
They're cute.
They're cute, fluffy, yes. Thank you. It took long enough. You've all had a few beers and you're very slow. So we can put them on a graph because there's only one real difference. Are they a cat or are they a dog? So we've got cattiness, we've got dogginess. We've got one axis. And we love mixing mathematics with cute animals. And let's look at some more pictures. And yes, I have been assured the one in the bottom right is a dog. Yeah, I was assured by someone. So again, we can see they're cats and dogs, but not so big on the cuteness. I mean, if you like that sort of thing, hey, whatever floats your boat, you know? And we can put these on a graph as well. So now we've got two axes. We've got cattiness and dogginess and and ah! And time for a bit of terminology. So we got some definitions we can use. The axes we would call dimensions in data science, or at least what little data science I know. And we're going to call the points on the graph the embeddings. The graph is 2 dimensions, so we have 2 embeddings. And I look like Ultraman when I do that. I never realized. So yeah, we're going to call the whole thing the index, because why the hell not? So now, let's get a new image. And let's try to figure out where would this thing fit on the graph, this cute little fuzzy wuzzy snowball. So, any takers? Top left, bottom right? Anyone?
Bottom right.
Bottom right, yes, I knew this audience participation thing would work. You know, we are really giving the Rocky Horror Show a run for their money here tonight, folks. So yes, it would fit on the bottom right, of course, with all the other cute puppies. We found the closest match, a match made in puppy dog heaven. So yeah, how did we do that? Well, we did it because we've been raised knowing what cats and dogs look like. We look at picture books as kids. We see cartoons. We see photos. We know what they sound like. We get cats and dogs. We grok the damn things. And that's pretty much how the deep learning models do it as well. They're fed a whole bunch of data, and then they're asked, with a new bunch of data, is this picture a cat or a dog? You get the answer right, you get a cookie. You get the answer wrong, you get a slap. And you go back and to the next picture, and you improve and you learn and learn and learn again. Kind of like parenting a child, if you either want to give them diabetes or a slap. But isn't that just classification? Well, yes and no. Really, what we're doing with neural search is we're looking at the features. So we're not looking at, is it a cat or is it a dog? But we're looking at, does it have a wet nose? Does it have whiskers? Does it have pointy ears or droopy ears? All of these different kinds of things. And then we can compare groups of things. Well, we can compare things with other things based on features. So yeah, in a way, a neural network model is kind of just like your brain. In reality, it is a little more difficult. I'm talking about wet noses, pointy or flappy ears. Often the dimensions a model uses, we don't really understand. They're black boxes, and there may be hundreds of them. So why give a damn? Because it's not just about fluffy animals. You can use this kind of similarity search in the medical field. You find someone with a weird lung condition, you can upload an X-ray of their lungs, find someone else who had the weird lung condition, find out what was wrong with them. Like I said, take pictures of your shoes, find similar shoes. Take pictures of the teapot your granny gave you before she died that you broke like an idiot, and you can find another one. So your dear old mother doesn't know the difference. Or things for online education as well. You can build a chatbot to make boring static courses more interactive, so you can learn more about the material. And all of these, we actually have examples, either running by different companies or just running on our own servers. And we're still pretty new. We're a startup that's under 2 years old. So I'll be honest, we don't have a lot of stuff running in the wild by big companies out there right now, but what we do have is pretty promising. You can search any kind of data as long as there's a machine learning model that can understand it. So you can search text in pretty much any language. There are loads of transformers models that can deal with English, Chinese, French, German, medical terms, even stuff like DNA, which when you think about it is just a string of text characters like GTAC. One of our community built a protein search engine, which is really cool. It has a streamlit front end, and all the results come back as these rotating molecules. The problem is nobody knows how good the results are because none of us are molecular biologists. But it looks really cool, and it returns results. You can do image search, you can do audio, you can do video, which is basically just images and audio over time. 3D meshes is really cool as well, and I really hope we can get an example going. People are using that. Companies are using that in the wild, but I don't have anything I can show you. And you can combine these things as well. It's like when you go to Google Images and search using, I don't know, cute fluffy dog, you get pictures back of a cute fluffy dog, hopefully. That's text to image. And you can do that with what we're doing as well, with Gina. So text to image, image to text, audio to yada, 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 yada. You name it, any combination. Can you find true love? When somebody builds a model for it, maybe you can. And you can use hundreds of pre-existing models. Me, I'm not very clever. I don't know much data science or machine learning. So integrating an outside model, that's tricky for me. Writing my own model, that's really tricky. But we have a thing called Gina Hub, so you can just integrate all of this stuff with one line of code. The chatbot example, I showed a screenshot earlier, and the fashion search example, they're each under 100 lines of code. Because a lot of this stuff, you can just pull it instead of having to write it and integrate it yourself. You can also fine-tune it for your use case. Like if we take the clip model, that's really good for image to image, or text to image, or image to text. But it's just really generally good. So if you're searching chest x-rays or teapots, or your favorite celebrities, it's going to be equally good at all of them, and not great at anything. But you can fine-tune these models as well with another one of our things. So yeah, like I said, if you broke your granny's favorite teapot, I'm going to say we might be able to help, but it's a stretch. You'd have to put the work in, but it could be done. The advantages of all this is it's semantic. So if you're building Zalando 2.0 and you're searching for scarlet clothes or vermilion clothes or crimson clothes, it'll match that with red because it has a mental understanding that all of these things mean red. without you having to actually implement a list of other words for red. It works with all disclaimer data types as long as there's a model and loads of plug-and-play modules. Traditionally, implementing this on your own, there's been a load of challenges because machine learning stuff, deep learning stuff is pretty cutting edge. You're using new versions of libraries, and they'll always clash with each other when you're trying to build something big. So yeah, we get around that and deploying it as well. We let you scale it up, replicas, sharding on Kubernetes, on Docker. It makes life a lot easier. And then you can run on, AWS, Azure, whatever you like. So yeah, our mission, open source neural search ecosystem, allowing, you can read. Why am I still talking? These are meant to be hidden. So you only really need 3 concepts. It's dead basic. So you've got a document, that's a basic data type. It could be text, image, audio, video, whatever. It's all wrapped into one document. Anything that goes into Gina and comes out of Gina is a document or a list of an array of documents. You have an executor. An executor does one thing to a document. So let's say you want to search the collected works of Shakespeare. Well, it's going to be difficult if you'd want to break them down into sentences first, right? So that's what an executor would do. It could break all of Shakespeare down into different sentences for you to search. Or it could encode an image into something a deep neural network could understand. And then you want to combine these executors into a pipeline and scale it up. That's where a flow comes in. I'll skip the bash stuff. I don't know how we are on time. Never been good at it. How are we?
5 minutes or so.
Okay. How many people here use the command line? A lot? Oh, okay. Awesome. My people, my friends. So I think of Gina as really a lot like bash. And I live on the command line. I'm a terminal junkie, in a manner of speaking. That could sound very bad if you read it the wrong way. But if you're building a Gina flow, it's just flow.add.add.add.add. It's like piping stuff with bash. And because we have a lot of plug-and-play modules, it's kind of like apt-get as well. You can just use a new encoder. If clip isn't giving you good results, you could use big transfer encoder. Or if, I don't know, one of the transformers models for text isn't giving you good results, you could use a spacey encoder instead. I personally go for spacey. I find it much quicker, and I know the guys, so we have drinks. So I'm a little biased. We don't have time to go through the notebook, and I don't have it on this machine. But if you want to look at how to build a meme search engine, the URL is there. So yeah, in short, you can build a neural search engine with very few lines of code. As I said, most stuff that I've built under 100 lines. You can do it pretty much all on the cloud now as well. We're really rolling out the cloud features. Scale it up for deployment on Docker, Kubernetes, all the stuff you need for most use cases is just there. If you want to break images down, if you want to process PDFs, if you want to take every line of a CSV file and break that down into something you can search, if you want to take JSON, whatever, the modules are there for you to do the job. And the result, just an AI-powered search engine for any kind of unstructured data. And it's all open source. So yeah, you can go wild with it, do whatever you like. Do crazy stuff. We're doing stuff with DALL-E right now, which isn't really raison d'etre, but we're having fun with it and just mucking about in the office. So you can build any kind of weird pipeline you want to do whatever weird things you want. Yeah, if you want to learn more, well, talk to me afterwards. Let's have a beer. But you can also go to learn.gina.ai. And if you want to join our community, we're on Slack. That's the best way to talk to us. If you have questions, our engineers are really good at answering them. We don't bite much. We run quite a few events ourselves. So Engineering All Hands, those are all the fancy pants technical talks about all the cool new features, and we invite thought leaders to join us and talk about their cool machine learning stuff. Or our office hours, where you can join us online for a drink, talk about your use case, talk about issues you're facing using Gina, and our engineers will help sort you out. And yeah, if you want to follow me, my data's on the, I don't know which way to point, on the left, on the my left, on the your right, there. Cool. All right. Yeah, that's me. That's Gina. Thanks, everyone.
Any more questions for Alex? Can I ask a dumb question?
Oh, there no such thing.
Might be.
Yeah, well,
How would you position yourself against something like Algolia?
that's a good question. I'd say we're completely open source, so you can do what you like with us. I haven't used Algolia much. If you want something out of the box, like there's an API, I'd say Algolia might be a better option.
But is one of them better for different type of data or something like that?
As I said, I haven't used Algolia much, but I would imagine Algolia is better for textual.
Yeah.
A lot of things can do text to text, and to be honest, that is when we surveyed our community, text search is one of the biggest things, either pure text or chatbots. I think that's just because that's how people imagine search. We're getting a lot of our community doing things like image search or multimodal, like text to image. Image to text, not so much, because even I can't see a use case for that. But we do have demos of image to text. So you can upload an image and find the line from Pride and Prejudice that matches it, which not a very useful use case. But I'm going to improve that. So.
I'm just interested, how big is the community?
We've got maybe 3,000 people on our Slack now. About 15,000 people in our GitHub community, if you can call it that. Stars. About 15,000 stars.
That's all that matters, stars.
Exactly. The investors love them.
The investors are stars. Anyone else got any better questions than me?
Oh, darn, they're perfectly adequate.
Nah, there we go. It wasn't so bad in the end. Okay. Then I'm going to invite Patrick De Silva up. I'm going to give you the one bit of advice that I didn't give Alex. Is it's good if you can stand here and speak into the camera a wee bit, because hopefully there's somebody still online watching. I don't know, and hopefully the microphone still picks you up from here. I think it should, but also can wave to the people that are there. No idea if there's anybody still there.
Wow, I turned them all off.
They're very important.
All right.
Questions.
So I just click, I guess.
Yeah, just left and right.
All right. Yeah. So talk is actually going to be pretty simple. I've been in the data science, machine learning space for about 4 to 5 years, and I saw a lot of products fail. And this is kind of a story of what to do and what not to do when you're trying to build one of those products. And yeah, it's things I've seen, things I've also went through. So I'm just sharing that with you guys tonight. That did not work. How do I? That worked. Okay, yeah. We often hear the statement like data is the new oil, but a lot of people don't actually know what to do with it. They don't know what that means, how to actually get something out of data. And so you need to start asking the right questions when you're thinking of building a data product. And I've just put some questions that I like to ask when I hear that someone wants to start a new product, because these are often the questions that are not asked and end up costing you a lot. And I have some stories to share on each of those questions. So I'm going to start with the first one. Yeah, so do your investors actually understand your product? That's something that doesn't sound like, why would you think of this? Because your investors, if they give you the money and they know what they're doing with it or why they want it, then that's basically all you need to know. But actually, the difference with a data product is that they're buying into what you're doing, but then they're going to use it for probably the rest of their company that needs to interact with it. And that's sometimes questions that they don't even bother asking because they don't think it's relevant. You know, they think they're asking you to build something, and then they'll figure out how to deal with it later, which is often not the case. And so, like, they often imagine like this thing that learns, or something that can become better on its own as time goes because you're going to get more and more data. But some machine learning models that I've seen in practice are not more complicated than the graph that you see on the screen. Yeah, you have a data plot, and you basically just trace a line through it, and it actually works better than all the complicated models you can think of, just because that's what works, and there's nothing more to say about it. The best example I knew about this is actually the first job that I had in the field. I joined the startup incubator, and their mentality was, we're going to pay you a full-time salary and as an employee, and you're going to experiment and try to build something that's relevant for the companies owned by for the companies that also, like, there's some other company that owns the incubator and other companies, and they wanted to provide value for these companies that they own. And so one of these companies came to the incubator and asked, like, we want a chatbot to reduce churn when phone calls arrive at the customer service center. And they just want to automatically filter those out, save some time, save the customers some time, and that kind of stuff. And so we did a POC. They were satisfied with the results, but didn't go with it in production. And then we did another POC, and the same thing happened. And then a third one, and the same thing happened. And then at the end, they were really happy with our work, and they proposed a deal to actually start going to production with something. And the 3 solutions that they asked for had no machine learning involved at all. Yet their actual statement as to why they want this was, we want to know what we can do in the machine learning space. And so you can imagine the disappointment when I'm being told, like, they want to know what I can do in machine learning, but their actual desire is to see like a button-based chatbot that just requires, let's say, a message and a bunch of buttons you have to click. And then when you click the button, it's already pre-programmed that this is the next message. No machine learning at all. And yet they're going to brag about this. They're going to market it. And so you're just sitting there thinking, like, maybe I spent my time with the wrong investor, you know? So that's something to think about. And I guess the best way to figure out if they understand it is to ask questions yourself. So you can ask back questions such as, what kind of data do you want to put into this? Like, let's say the product is defined already. Now you just want to know if they understand. So what kind of data do you want to put in? What do you expect that the chatbot is actually learning? Yeah, or the product that you're building, if it's a machine learning model for search or for predictions, what is it predicting? Who is going to check the data quality over time? Yeah, let's say you're doing a search engine and it's for fashion. Well, maybe it works in the summer, and then 6 months later, well, if it works for summer clothes, you don't want to recommend summer clothes in the winter because that doesn't make a lot of sense. So who's going to make sure that these things happen? And if you realize that maybe it makes sense in their head as a business concept, but they don't have the capacity to actually deal with something like that, then maybe you do six months of work, and then afterwards, when it comes to time to go to production, there's nothing to do with it, so the project basically dies. And this happens a lot. All right.
Just one question.
Yes.
Can you define investors? So do you mean more like stakeholders or like VCs or something like that?
People that contribute to the project without putting their time in.
But they will be
So they could be putting money or giving you resources, employees.
Sure, but they will be the users of the product or not?
No, not the users. Yeah, I mean, like, for instance, if a company wants to hire you to build a model, then I'm thinking like the CEO or something like that. But if you are the one building your own machine learning product, then we could be talking about actual investors, right? But it's perfectly fine to think of this also as the client if you're building something for them. Yeah, the whole idea is just you're building this thing for someone. Does that someone know what to do with it once you're done building it? Yeah. So It's a bit weird that I show this slide without actually starting to talk. But yeah, this is a situation I've encountered actually very often. You talk with people that are interested into building a solution, and you come up with a great plan. Technology is amazing, the model works, the data is great, you can make nice predictions, and then it goes into production and you're not there anymore. Yeah. Maybe they hired you for a short time period and now they just work with what they have and they have to maintain it in a certain way. And it's not data scientists or machine learning engineers that maintain this, but people that generate the data and then put it in their database to probably a web portal or something like that. And then this data has to be managed. And you have a machine learning model that trains on that data. So the model has to be managed as well. And the question is, how are they going to actually handle that? Yeah. Just 1 second. Yeah. So the biggest issue with why it's hard to manage these products is because we're used to thinking of software as rule-based algorithms. So basically, if I'm a person and I ask an engineer, I need something that does this, then they expect, okay, there's going to be rules that are going to generate my output, and that's how it's going to work. But a machine learning engineer does statistical predictions. So it's an algorithm that generates guesses, so to speak. And so you always have to deal with the part where the guess is wrong. And that can dramatically change how you work with the model depending on the industry, the kind of users you have, the kind of customers you have, because sometimes they're not the same. And I'm going to give you 2 examples. So one example where they manage the guessing part really great is N26 chatbot. I don't know if you've ever used it or if you're an N26 user at all, but basically when they got it out, I think it was about 3 or 4 years ago, their idea was very simple. You can talk to the bot by default. So when you have a question and you click on the chatbot window, you start talking to the bot immediately. And it says to you up front, anytime you're not happy with talking to the bot, you can just type human, and then you start talking to a human. So that basically leaves all the room to play for the chatbot to fail, make mistakes, collect some data about why it failed, how did it fail, how the user was not happy with the conversation. And so even if at the beginning the chatbot had 1% problem resolution rate, it's still 1%. And every other user would just have typed human and gotten to a human, and that's what happened before. So basically that gave them the room to play to help their users and train their chatbot at the same time. And even if they never got to perfection, which I assume they don't, I mean, like at this point, I wouldn't be surprised if their success rate with the chatbot doing 100% of the conversation would be somewhere around 30 to 50%. You know, that's still an insane gain over 0% without a chatbot, right? Even if they never reach that perfect rate, being imperfect is okay, because they have to live with the fact that anyway, the algorithm they're using is not meant to be perfect, it's meant to be guessing. And it still cuts them an insane amount of costs, saves the users an insane amount of time, and it just works, yeah? Whereas there's the other kind of approach that tends to fail very often, which is that your goal is to minimize the error in the guessing as much as possible. So basically, you want your guesses to be perfect every time, yeah? And then you don't know what to do in the case where there's an error. So these are usually the kinds of products that induce like a very poor user experience, because let's pretend you have like 99.5% accuracy, right? So anytime a user would use your model, one time out of 200, they wouldn't work. If you have 10,000 users, that's a lot of unhappy people, right? And only the unhappy people are gonna complain, leave bad reviews, tell that your product doesn't work, and it basically kills your product up front, even though the margin for error is super small. Yeah, okay, one last thing I want to check. Okay, no. So, do you have the resources? that's another question that we don't ask very often when trying to build these kinds of products, because it's not just about having a team, having the money, having the data. It's also about having it work for your company. So let's say, for instance, you want to build a search engine. Okay, so you want to build a search engine, and so you get a data scientist on board. You get some people in your company that are going to generate and label the data, or maybe crawl it on the internet. And then you get your model trained. Your model goes into production, and then the issue is like the people that will maintain the model afterwards, they're not there, or maybe they're busy working on other things, or you don't have the time to hire them, or all these kinds of problems that can show up. If these things are not in the plan, by the time you've reached a certain stage in your machine learning development, some things are going to break, and then the project is going to die. I've actually experienced this myself. So when I was working in a company, the founders themselves of the company were working on labeling the data. So finding the data, labeling it, and then they hired a consultant to build the model, and then they had the model working. And then one of the things that they didn't have is a way to put their search engine behind their website. So their website had so many problems that when trying to integrate the model that they had behind their website, they didn't have the resources for back-end development just to make the connection between the two. So it sounds weird, because why would you invest so much money into something you cannot integrate? But if you have no one asking the question, that's what happens, yeah? So yeah, I think that's pretty much all I had to say. But I mean, of course, I went through a bunch of other amazing stories that I'd love to tell you. So if you have any questions or are curious about anything, just shoot your questions. Thank you. So let's grab a beer.
I'm just going to quickly check that nobody online had put any questions in. Give me 2 seconds. Everyone's so quiet. Maybe they're quiet online as well. Yeah, they're quiet online. But Monica, Silvio, and Sohail, I hope you enjoyed the presentation. So, yeah, we can. That's it for for tonight. Thanks everyone for coming. Thanks for our speakers. Maybe another round of applause for our speakers. Oh yeah, we are actually getting thumbs up online. Yeah, pleasure. Thank you. I'm not making that up. I can even show it after. Yeah, I should do actually. We'll do this every month, and like I said, if anyone's interested in speaking, come and ask us. We've got about another hour here, so we've got still a fairly full fridge that we can use. So yeah, feel free to stick around and have a chat. Cheers.